than is necessary. So this is lesson 2, and I've called it the rise of the operators. What do you think about that? No.
I have no idea what that means.
Yeah, you're probably going to miss out on a bunch of the puns I have in this, but that's okay, because I think they're funny.
Oh, wait, Rise of Skywalker? Maybe?
No, I think there's a Terminator movie called Rise of Machines or something.
Well, there's a Star Wars movie called Rise of Skywalker.
Yeah, then let's go with that one. There we go. All right. So first, arithmetic. Raise your hand if you are good at arithmetic. JP, you're not good at arithmetic? Like simple, basic addition, subtraction, multiplication, division.
Terrible at it.
You're terrible at it? What's 1 plus 2, JP?
5.
All right. Well, so arithmetic, we have these things, right? We have like 1 plus 1. We have 7 times 2. And these
Operations.
are called operators. And so then this whole thing then, right, Lucy, would be an operation. Right?
Mm-hmm.
So what we can do then is we go, okay, so we have mathematical operators, right? And you guys know all the mathematical operators. You know what they do, right? You know what the plus sign does. You know what the minus sign does. You know what the multiplication sign does. You know what the division sign does, right? And mathematical operators combine mathematical objects. And these are most often numbers. JP, as you get older, Lucy, you're probably already starting to deal with this, variables.
Yeah.
Right? So they're not always numbers, but most often mathematical operators deal with numbers, digits, right? So in the same way, in logic, we're going to have a bunch of operators, and they're logical operators. So in math, we have mathematical operators. In logic, we have logical operators. And in math, the mathematical operators deal with mathematical objects, which are mostly numbers. So what do we think logical operators are going to deal with?
Words.
Not words.
Propositions.
Propositions, right? They're going to deal with logical objects, most often propositions, right? And our propositions, of course, we're going to use P, Q, R, and S. Right? That's usually what we're going to be. If we run out of those, and we'll start adding more letters. And here's all the basic logical operators.
The only one I know is the 3 dots, because that's also in math, and that means therefore, right?
There you go. That one means therefore. And we're going to learn each of these. And they're not that difficult once we get it. All right?
Mm-hmm.
So first, we're going to use negation. Right? And I've got, that's a negation ghostwriter. Which,
Ghostwriter.
Have you guys seen Top Gun?
Yes.
Okay. Do you remember when he says that's a negative ghostwriter?
Oh.
So that's a negation ghostwriter. Okay. So this negation looks like a minus sign, but it has this little hook on the end. Okay. And what it means to negate something is it declares that what it's saying is actually false. Right? So it like subtracts the truth of a proposition. Okay? So if we have the negation before a proposition, what we're saying is the proposition we're talking about is false. Okay? So we have this, right? And this, right, negation sign followed by P simply just means not P. right? Or P is false. Okay? It's not the case that P is true, right? So if not P is true, then P is false.
Okay.
All right. Do you understand that, JP?
Yes.
A little bit or not?
I understand, but no.
Okay. All right. So this first one is just the negation. All right. And you can think of it as just subtracting the truth from the proposition. Okay. Next is we have conjunction, junction, what's your function? All right. And do you guys remember that song?
Conjunction, junction, what's your
Look it
function?
up,
This is in one.
right? So,
Hmm.
so then this sign is called a conjunct, and it connects. And what's it going to connect?
Propositions?
Propositions, right? So we've got con, which means with, for you Latin scholars out there. So we've got and but, right? So P conjunct Q just means P with Q or P and Q. Okay. So if I had proposition P, if it was JP is a boy, and proposition Q was Lucy is a girl, then JP is a boy and Lucy is a girl.
So it's basically an equal sign, but with
No.
No, it's not an equal sign because JP is a boy does not equal Lucy is a girl. Right? It's more like an addition sign. Right? I'm just adding these things, connecting them together, and saying both these things are true. Okay?
Mm.
So if P is true and Q is true, right, then P conjunct Q is true. Right? So if Q was Lucy is a boy, and P was JP as a boy, then would P conjunct Q be true?
No.
No, because the Q part is false. All right. Are you tracking that, JP? Okay. So that's the conjunct. And then next we have the disjunct. And every disjunctional family is different. Lucy, I think you kind of get it.
I don't know what that is.
No. So dysfunctional.
Oh, I thought there's like, is it from something?
It's basically from the start of Anna Karenina,
Oh,
which is a very, very big book.
my mom's reading that. She would get that.
Ah. So then this is the disjunct sign, right? And it's just, right? So the conjunct sign was this, right? So we just turn it upside down and we have the disjunct sign. And so whereas a conjunct says both are true, what is the disjunct going to say, do you think? So it's not going to say both are false. It's going to say at least one of them is true. So this is where we get the either or.
Okay.
Okay, so either this or that. And we call this inclusive, right? Which means that this and that can both be true. Okay. So then when we get P or Q, P disjunct Q, we're saying either P is true or Q is true or both are true. All right.
Mm-hmm.
And so the way we would say this is we could just say P or Q, or we could say either P or Q. All right. And then what would make this true is simply as long as both P and Q are not false, then this is true.
Okay.
Okay, so if both P and Q are false, then this is false.
Okay.
So we just have to make sure one of them is true for this to be true. All right. So just checking in to see what my condition is in. That's a song. Just checking in to see what my condition is in,
Oh.
right? And so this is the conditional sign. It's an arrow, and it always goes left to right. Right? So we never are going to have an arrow that goes this way in logic. All right? It's always going to go left to right. Right? And conditional says, okay, if this condition is true, then that thing. Okay, so conditional starts to get a little bit more advanced, a little bit more complex. Okay, and there's two parts. There's the if part and the then part. And we have names for each of those parts because they're two conditions.
Is that like the dependent variable and the independent variable?
Yeah, very much like the dependent and the independent, right? But in logic, we call the independent the antecedent. All right. And what we're saying is it's sufficient. And what's another word for sufficient?
Good enough.
Enough, right? This is really hard to draw and write on. There we go. Enough. All right. So the antecedent is enough. If the antecedent is true, it's enough to give us the following condition. All right. And the antecedent, right? Do you guys ever play poker?
Yeah, you ante in.
And you ante in, and what is that?
It's before you play.
Yeah, right? So it's the ante is the before, right? So the antecedent is this part. Okay, it's the before part.
Mm.
The
It's like in grammar.
yeah. The other condition is called the consequent. Okay. So the consequent is then the necessary condition. Right? So if the antecedent is enough to give us the consequent, then if we don't have the consequent, then we don't have what?
Antecedent.
The antecedent. Okay, because if the antecedent was there, the consequent would be there. Okay? And so this is going to look like if P, then Q. All right? So that's how we'd write it. So if P is true, then Q is true.
But isn't it the same as the first one, like when you said if JP's a boy, like JP's a boy and Lucy's a girl?
I was just saying that they are. They're saying is if.
Right, but I just said that. So I could say the following. If JP is a lizard person, then Lucy is a girl.
False means that she's not a girl.
So it's actually true, which is weird. And right? So
Not a lizard person.
I know, but I said if you were.
Well, but that doesn't mean I'm not a girl, anyways, right?
No, because it's only so if I deny P, I don't have to deny Q. Right?
If you deny Q though, then you
If I deny Q, then I have to deny P.
Because it's necessary.
Yeah. Right? So what I can say then is I can say, okay, well, if JP is a lizard person, then Lucy's a girl. But, okay, right?
Mhm.
Lucy's a girl, right? So, no, it's not if Q then P, right? So when we do this, we have to say it in the proper order, okay? And to make if P then Q true, it's true if P is false or Q is true.
But P can be true and Q can be true at the same time, so, right?
Yeah, and so that would still be right because this is our disjunct.
If they're both false, is that okay?
Yeah, if they're both false, this is still true.
Okay.
Right? So if P is false, this is true. If Q is true, this is true. Right? So
But
if,
it can't be if P is true and Q is false. It is false.
correct. If P is true and Q is false, this is false. Mm-hmm.
But that's like the only situation where it would be false, but all the other combinations would be true.
Yeah. So the only time that this conditional is ever false is if P is true and Q is false. That's the only time. So what we say then about a conditional statement is it's very strong, right? And that is, it's always going to be more likely that it's true than false. It's got a lot of strength to it, okay? And then from the conditional, then we go into the biconditional, all right? And there's a Queen song where Freddie Mercury, the lead singer of Queen, sings, I want to ride my bicycle, bicycle.
Oh,
All
I've
right.
heard that.
So the biconditional then is the conditional,
Do they both rely on each other?
then they do, right? So what we say is if and only if, all right? So if this, then that, and if that, then this, right? So we just take the conditional and make it go both ways. All
Do they
right?
both have to be true or they both have to be false?
Yes. Mhm. So if P, then Q, and if Q, then P. And the way we say that is if and only if P, then Q. Okay? So this is just the way we say it. But if you want to read this as if P, then Q, and if Q, then P, if that helps you, that's fine. Okay? So if the conditional if P, then Q is true, and the conditional if Q, then P is true, then if and only if P, then Q is also true. All right? And that is each of these conditions is both necessary and sufficient. Okay, so we use this, the biconditional, a lot to define concepts and terms. Right, so you might say, okay, well, if this liquid is water, then it is None of you guys haven't taken chemistry yet, right?
I'm doing a little bit, and I do physical science, so it's chemistry and physics.
Okay.
H2O.
H2O, right? So do you know that, JP? All right. So if this liquid is water, then it's H2O, right? That seems completely true, right? And if this liquid is H2O, then it's
Water.
water, right? So this is where we'd use biconditionals. They're very good at defining things, all right? Questions over the biconditional. All right. Then we get sew a needle pulling thread. Yeah, you guys both got that one. That's
Yippee.
right. All right, so this is just our therefore, so, wherefore, hence, thus, right? These are conclusions, right? And we use this when we're putting together operations in an argument, okay? And so the premises give us this new proposition, this conclusion. And we set this up like a math problem, right? So we'd say, okay, P on one line, we say P is true, Q is true, therefore P and Q, right? So this operates a lot like our equal sign, right? Kind of just our conclusion, right?
Is it supposed to say that P is true or Q is true, or how do you know that, like, P is
Yeah,
true?
so
or Q is
whenever we do an argument, right, we're going to have premises. We're going to have like premise 1, premise 2, and you can have as many premises as you need, right? And then we're going to have conclusion. So we're always going to just assume over here.
I can't see it.
We're always going to assume in our arguments that what we call our premises are true.
Okay.
Okay. So that way we just have to write the proposition.
Is there a way that it would not be true? Like if you were trying to make like a different type of.
Yeah, so once we go through and just see what the conclusion would be based on the assumption.
Would you put a negation?
No, that's just a Q, sorry. It's hard to write. All right. So once we go through and just go, okay, that's going to give us P and Q. This is hard to draw. There we go. Then, right, and that would be true, assumed, right? And that would mean that this is valid. Okay. And then we'd go back and then actually ask the question, okay, is P true? Is Q true? All right. And so then we'd check for soundness. Right. So we always start by just assuming the truth of the premises and seeing what the conclusion would be if they were true.
Okay.
All right. So P is true and Q is true, therefore P and Q is true. Okay. So review time. What's this sign?
Negation.
Negation, and what does it do?
It says it's not true.
It's not true. Very good. So not P, not Q. They're not true. What is this sign, JP?
Conjunction.
Conjunction, conjunct. Very good. And what does it do?
Says they're like Both true.
Both. Very good. With and but, they're both true. All right, so P and Q, both true. All right, this one, Lucy.
Disjunction.
Disjunction, and what does it do?
It means that at least one of them is true.
Yeah, so either or, at least one of them is true. All right, this one, JP.
Um,
Oh, it's over there.
means
All right, Lucy, just tell them the name of it.
Conditional.
Conditional. Okay, and then what does it do, JP?
that has to be true.
Yeah, right? If, then. Very good. Right? If P is Q is true, then Q has to be true. Very good. Right? So then what's this one, JP?
That is a line.
This one. So remember, this one was conditional, so what's this one?
Bionicle?
Biconditional. Right? So bi just meaning two, right? Biconditional. All right. And what does it mean, Lucy?
If and only if P, then Q.
Yeah, if and only if P then Q. So it basically combines if P then Q and if Q then P. All right. And then we've got this one. That's tough to see. With the three dots. Lucy.
So
Therefore, so, hence, and thus. And what does it do?
it's like conclusion.
Yeah, it gives us the conclusion of an argument. Right? Any questions over that?
Why does the names have to be so hard to remember?
Why does the name have to be so hard?
It makes sense. Like negation sounds like negative, which is like a not. Conjunction, like it's like a conjunction in grammar. Disjunction, you got to remember that one. Conditional, it's like a condition.
Right.
Biconditional
Well,
is like there's
just
two
for condition.
arrows. Condition, because that's
Yeah.
just the way they do it. It sounds the same. And then biconditional is two arrows, like two, because bi means two, and then three dots. You have to remember that one.
So think of it this way, JP, for the conditional, right? Are you ever playing around with Lucy or Tommy or Claire, and they want to play a game, but the last time you played, like you didn't like what someone was doing, and you say, look, I'll only play on this condition, right? That's all it is with a conditional, right? If you guys promise not to team up against me in this game, then I'll play the game, right? On that condition. And if you guys break that condition, I'm out, right? Does that help clear it up?
Kind of.
Kind of. It's good though, because now you guys are going to have worksheets to continue to look at that terminology and concepts and really get it in there. Because they're tougher words, right? But I don't know that they're tougher than, right? So if you had never taken arithmetic before, and then I was like, okay, JP, this sign is called the addition sign, right? Or subtraction sign, or multiplication sign, right? Those would seem like, why do these words have to be so big and tough, right? So they're not any bigger or tougher than that. They're just new. They're just new. But I have confidence you can get it. All right. Other questions?
How does but like mean that they're both true?
Yeah. So but and yet, where we use these in ordinary language, in a different kind of way, they're still conjunctions, right? They're still connecting things, right? So if I said, I'm, or let's say this way, your mother is a Gilchrist, but you two are Cotters,
Oh yeah.
right? It's no different than saying your mother is a Gilchrist and you two are Cotters.
Yeah.
Right? It's just we use the but in there to kind of highlight like the contrast, but they're both true. Mm-hmm. Yeah. Other questions? None, JP? All right. I'm going to discard the ink annotations. So then I'll